So what is the definition of Laplace transform? This is the capital F of S is equal to 0 to infinity f of t times e to the power minus st t dash. So now we are representing the function or any frequency function, any signal in terms of time domain. So we are making integration and we are converting into S domain. So f of S is equal to, that is the Laplace transform. S is the complex number. S is the complex number. So we can represent this S as a pi plus j omega. Just before we had seen this in our frequency considerations lecture. So we can represent this pi plus j omega, or you can represent j plus j omega, or x plus j omega, or jy. It's not a matter. You can use, in some books they use pi plus j omega, some books they use a plus j omega, or a plus jb, and in some books they use x plus jy. It's not a matter how you represent the s, but the thing is, this is called real part and this is called imaginary part. And that is how we have studied how can you represent that in the polar plot in terms of zeros and poles. Okay, so S is a complex number. We call this is a complex number because it has imaginary part. And here, of course, here we are talking about t and t dash. So this you can just never mind for here now. So this is the definition of the Laplace transform. F of S is equal to integral of 0 to infinity f of t times e to the power minus st t dash. This is the d omega t. T dash is nothing but a d omega t, the first derivative of the function. So where S is equal to a1 plus ib1, a1 is the real, b1 is the imaginary, and we are taking a1, which is the function of real valued variable, and turning into Laplace transform, which is a complex valued variable. So for example, if you have only 5 volt, that is the real part. But when we convert into Laplace transform, we are also adding this j omega. This is the imaginary part, that is with respect to frequency. Remember, S is this is a complex number. So this is the standard definition of Laplace transform. Try to remember. So now, in this part of the lecture, we are not really going to study like what is Laplace transform, what kind of formulas you have to use, and so on. That is the basic Laplace transform that you may studied already in your mathematics course. And here in this part of the lecture, we are going to look how to apply Laplace transform to circuit analysis. So, but I will also try to give you some examples and some formulas during the lecture when we see some examples. Okay, so you are transforming the circuit from time domain into S domain. First thing, and solve the circuit using nodal analysis, mesh analysis, or source transformation, superposition theorem, or any other circuit analysis technique that you are familiar with. So I think these kind of analysis maybe you have studied in your circuit theory or network theory course. So we will use some of this analysis. If you do not remember, I will explain that during the examples. So some kind of mesh analysis or nodal analysis, we will use some different methods. And take the inverse transform of the solution and thus obtain the solution in the time domain again. So these are the steps. So first you are converting or transforming the circuit from time domain into S domain. After you convert into S domain, you are doing some kind of analysis using network theory. After you perform the analysis and find the formulas, then again you are making the inverse Laplace transform and bringing the signal back to this F domain. So for example, this is the one function, output function f of t. So you are making the Laplace transform, and here you are getting the same output function in terms of in the S domain. And now I have to make the inverse Laplace transform. Inverse Laplace transform. Then again, I am getting the original function in time domain. This is just to analyze the output function. This is what we have to do. So transform the circuit from T domain into S domain is something new you are going to learn now. So you should revise your circuit theory and mathematics course for Laplace and mesh analysis, nodal analysis, and so on. So I recommend you to recall your memory, what you have studied in your network or circuit theory course about these different analysis methods, nodal analysis, mesh analysis, superposition theorem, and so on. And also you try to remember, if you already studied about Laplace transform, what kind of formulas you have to use to convert from time domain into S domain. So if you have those basics, then it's easy for us to see this course further.